All right, we're going to look at our test review on periodic functions. First two questions here deal with angular and linear velocity. In question number 1, we have a child spinning a rock at the end of a 2-foot rope at the rate of 120 revolutions per minute. And the question asks us to find the linear speed in feet per minute when the rock is released. Anytime we're doing questions like this, we always want to start with the rate that's given to us. In this case, the rate that we have given is 120 revolutions per minute. So 120 revolutions per minute. And then for my answer, I'm looking for an answer that has the units feet per minute. That's what I want to end up with. Well, if he's spinning at 120 revolutions per minute, we need to cancel out that revolutions unit because we don't want that in our answer. And so I'm going to multiply by 1 revolution here on the bottom. And I know that 1 revolution of the rock is going to be equal to the circumference of the circle that rock is making. Circumference is 2 times pi times r. And in this case, my r is 2 feet. So revolutions cancel out. And if I look at my units that I have left remaining, I've got feet per minute, and that is exactly what I want for my answer. So I'm ready to multiply everything together. And I get 480 pi feet per minute. Or if you prefer a decimal answer, 1,507.964 feet per minute. All right, let's move on to question number 2. In question number 2, we have a wheel of a bicycle whose diameter is 26 inches, and the bicycle is traveling at a speed of 25 miles per hour. And we want to know the angular velocity in revolutions per minute. Well, 25 miles per hour, that's my given rate. Remember, we always want to start with whatever rate is given. So I have 25 miles per hour. And the answer units that I'm looking for, revolutions per minute. Revolutions per minute. So I know that I want to end up with revolutions on top. The way that I can convert to revolutions is again by using circumference, which is going to be 2 pi r, and in this case my radius is going to be half of this diameter, which will be 13 inches. But that poses a problem because my distance unit that I have right now is miles, and so I need to convert miles into inches so that I can use that 13 inches. So 1 mile is equal to 5,280 feet. So I can cancel the miles. And then 1 foot, of course, is 12 inches. Now I can cancel the feet. So now I have inches on top, and I can convert that to revolutions. 1 revolution. So 1 revolution is equal to 2 times pi times 13 inches. Circumference formula, 2 pi r. So now I can cancel inches. And so in my numerator, now my unit is revolutions. And remember, if we look back at the problem, I'm looking for an answer in revolutions per minute. So right now I have revolutions, but unfortunately it's per hour. In the denominator, I still have hours. So we've got to do one more conversion. Whoops, let me go back to my blue. There we go. Times 1 hour is equal to 60 minutes. Now I can cancel out the hours, and I'm left with revolutions per minute, which is what I wanted for my answer. Multiply everything on the top, multiply everything on the bottom, and divide. And if you do that, you get 323.206 revolutions per minute. All right, let's move on to question number 3. Here we have a periodic function, and we want to find the value of the function at some various x values. The important thing about periodic functions is the period the amount of time on the x-axis that it takes to complete a full cycle. So if I start the cycle here at 0, it goes up and then back down to 0, then down into the negatives, and then it comes back up to 0 and completes the cycle right here at 6. And so that means that my period equals 6. And so what that means is that for any x value that is a multiple of 6, at that x value, I'm going to be right back here at the beginning of the cycle, function value of 0. So for my first question, f of 24, well, 24 is a multiple of 6. And so that means that when I hit 24, I'm going to be right back here at the beginning of the cycle, and my function is going to be equal to 0. Now the next one asks me to find f of 41, and in this case I want to find a multiple of 6. Since 41 is not a multiple of 6, I want to find a multiple of 6 that's close to 41, like 42 for instance. 42 is 6 times 7, and so when I get to 42 on the x-axis, that means that I'm going to be right here at the beginning of the cycle, or you could think about it over here at the end of the cycle, either way, but that's going to be when x is 42. So for 41, we're going to back up 1 unit from either of those places, and then go to the function value, which is right down here at -2. All right, let me erase those markings, and let's do -25. So -25, again, not a multiple of 6. The closest multiple of 6 would be -24. And so when I get to -24, I'm going to be at the end of the cycle, or you could think about it at the beginning of the cycle, either one. And then -25 is going to be 1 more unit to the left. And so again, that puts me at the same spot in the cycle where my function value is -2. All right, let's move on to questions 4 and 5. In these two questions, I'm simply asking you to sketch a graph of the parent function and describe the parent function for me. So the parent function for sine looks like this. It ends right here at 2 pi, goes up to 1, down to -1. The domain for sine is all reals. Sine keeps going forever. There's no x value that we can't plug into sine. The range, however, is very limited. It only goes between -1 and 1. Or if you prefer to use set notation, you can write your answer like this. Either way that you would like to write your answer is acceptable. The amplitude for the parent graph is 1. Remember, the amplitude is the distance from the middle to the top, or the distance from the middle to the bottom. And in this case, that's 1. Period is the amount of time that it takes to complete one cycle, and that's 2 pi. For cosine, the cosine graph is similar, except that it starts up here at 1. And our cosine graph should look like that. This minimum point occurs at pi, and then we finish the cycle at 2 pi. And the minimum, of course, is down at -1. Domain, again, all reals. Cosine goes on forever. There is no x value that I cannot plug into cosine. The range, though, again, is limited from -1 to 1. And we can use interval notation either way that you like. Amplitude, again, is 1, and the period, again, is 2 pi. So notice domain, range, amplitude, and period are the same for both sine and cosine. All right, let's move on and sketch some graphs. Here on question number 6, we've got a sine of 2 times x minus pi over 4. So I've got two transformations here. The 2 here, that's a b. If we compare that to our basic y equals a times sine of b times x minus c plus d equation, this is the b transformation, which is going to affect my period. And then minus pi over 4, that's a C. It's a horizontal translation. So I want to write out what those are going to do to my graph. First of all, our period for the graph is going to be 2 pi divided by b. So in this case, 2 pi divided by 2, which is going to equal pi. So that means that when I sketch my sine graph, I need to complete a full cycle in pi units. Pi is my period. And then I've got a horizontal shift here. I'm shifting to the right pi over 4. All right, so let's sketch a graph. I'm going to count by pi over 4s because I'm shifting right pi over 4. I need a period of pi, so I think pi over 4 is going to be a good increment for me. But I'm going to let 2 squares equal pi over 4. And that would be pi, and then I'll go 1, 2, 3, 4 more. Wait, that's 1, 2, 3, 4 more, and that'll be 2 pi. Now remember, we're shifting to the right pi over 4, and so that means that my middle line here, the middle line should start right here at pi over 4. That's going to be the middle line of my graph. The period is pi, and so I'm starting here. I need to finish in pi units. And the way that I've labeled my graph, 8 squares equals pi units. And so if I count 8 squares, 1, 2, 3, 4, 5, 6, 7, 8, that means that I should finish my cycle by this point, which if you notice is pi over 4 to the right of pi, which is shifted to the right pi over 4. And my amplitude here is still 1. That hasn't changed. We didn't have a change in amplitude. So I'm going to mark this point and say it's 1. Mark down here, say that's -1. And so then I could mark off the top and the bottom of my window pane and find the middle, which it looks like it's right here. And now I'm ready to sketch my graph. I'm graphing sine, and sine starts in the middle of my window pane. So I'm going to start right here, and sine goes up, comes back down through the middle, bottoms out, and we're back to where we started by the end of the window pane. And then I'm going to sketch one more cycle. And there's our graph. All right, let's move on to number 7. Here in number 7, this time it looks like we've got an amplitude change. I've got an A here of 3 and plus 2 here at the end. That's a D, that's a vertical shift. So for this graph, my new amplitude is going to be 3. And remember, amplitude is always a positive value. Amplitude is a distance. That negative is a different transformation. It means that we're going to reflect the graph over that middle line. We're going to flip the graph over. But the amplitude is just 3. And I have a vertical shift here up 2. So whoops. Let's try that again. All right, so I'm going to say this is pi and 2 pi. So my period is still going to be 2 pi. It's normal. The graph is shifting up 2. So I'm going to mark that off as 2. So this is going to be the middle line of my graph. My amplitude is 3. So I'm going to count up 3 from my middle line. 1, 2, 3, and mark off there at 5. And then I'm going to count down 3. 1, 2, 3. That means my minimum is going to be at -1. And so here's the top of my graph, and this is going to be the bottom of my graph. And my period here hasn't changed. It is 2 pi. So I'm going to finish by the time I get here to 2 pi. Erase some of those extra marks. And of course, we're starting, since we don't have a horizontal shift, we are starting at 0. And here's the middle of my window pane. All right, so I've got my window pane drawn. Now I'm going to go back and look and notice that I'm graphing cosine. This is a cosine function, but remember we had that negative. Normally, when I graph cosine, it starts at the top of the window pane, but since there's a negative there, we're going to start at the bottom. And we're going to cross 0 in the middle here, hit our maximum at the middle of the window pane, 0, and then back to the minimum. And so there's our cosine graph, and we can do one more. Let me do one more cycle. And there we go. Let's move on to the next one. Here on number 8, I've got two transformations, 1/2 here, so that's an amplitude change, and then a 2 here in front of the x, that's going to affect our period. That's a period change. So for this graph, amplitude is going to equal 1/2, and the period is going to equal 2 pi divided by b, and in this case that equals 2 pi over 2, which equals pi. So pi is my new period. All right, so here we go. So I haven't had a horizontal shift. Let's see, the period is pi, so I think I'm going to count by pi over 4s. Let that be pi over 4, so pi over 2, 3 pi over 4, pi. And then this would be 4 more marks later. This would be 2 pi. I'm going to mark this off and label it 1/2, negative 1/2. I don't have any shifts here, so my window pane is going to start right here at the y-axis. The midline is the x-axis, and my period is pi, so that means I need to finish the graph by the time I get to pi. Amplitude is 1/2, so that's the bottom of my window pane. Here's the top of my window pane, and there's the middle. All right, again, I'm graphing cosine. And cosine normally starts at the top of the window pane. So we're going to start at the top. It's going to cross the middle, reach the minimum, back to the middle, and back to the top by the end of the window pane. And I'll do one more cycle. There we go. All right, question number 9. So this is the one question that involves all 4 of the transformations. First thing we should do is write out what all the changes are going to be. So I have an amplitude here of 4. That comes from here. B, C, D. I'll label them all. I have a period change. Period is going to be 2 pi divided by 2. Which again is pi. I've got a horizontal shift. Since it's minus, we're shifting to the right, pi over 2. And I have a vertical shift up 3. All right, so here's our axis. Since I have a period of pi, I would probably like to count by pi over 4, and my horizontal shift is pi over 2, so I can easily find pi over 2 if I count by pi over 4, so I think that's going to work. Pi over 4, pi over 2, 3 pi over 4, this would be pi, and then 1, 2, 3, 4, and that would be 2 pi. On my y-axis, I have an amplitude of 4, a shift of 3, so I think I can count by 1s, and that's going to work. So there's 3. So that's going to be, 3 is going to mark my middle line. Actually, I'm sorry, let me back up. Once you've labeled your axis, when you're doing all 4 transformation, I think it's always best to start by finding the point CD, by doing the horizontal and vertical shift. So I'm going to start here at the origin. I'm going to go right pi over 2 and up 1, 2, 3. And that point right there, that is the CD point. That starts the midline of my window pane. So here's the middle line of the window pane. I like to do amplitude next. Amplitude is 4. So from this midline point, I'm going to count up 1, 2, 3, 4. So there's the top of my window pane. And I'm going to count down 4. 1, 2, 3, 4. And so that's going to be the bottom of the window pane. All right. And the last thing that we have to do is find out where the window pane is going to end. We need to count out the period. The period is pi. And on my graph, pi takes up 8 squares. So from here at the beginning of my window pane, I need to count 8 squares. 1, 2, 3, 4, 5, 6, 7, 8. And so that's going to mark the end of the window pane. All right, so we've got the frame. I'm going to draw the midline right here in the middle. And now I go back and look and see that I'm graphing sine. And so sine normally starts in the middle of the window pane. So I'm going to start right here at the middle. It's going to go up and reach the top, come back to the middle, go to its minimum, and then back to the middle. There's one cycle. I'm going to do one more cycle. Top, middle, minimum, and back to the middle. There we go. And those are our graphs. All right, on the next page, we've got some matching where we're trying to look at the graph and match it to an equation. The first thing that I like to do on these is to identify the middle line of the graph. And in this case, it looks like the middle is right here at -1. Now, unfortunately, that doesn't help me narrow down my choices because all of the choices have a -1 at the end. So let's look a little bit further. If I count my amplitude from the middle line, I can count up 1, 2, 3. It looks like I have an amplitude of 3. And so now that narrows it down to this list of choices over here. I know it's not any of these because all of those graphs have an amplitude, or those equations indicate an amplitude of 2. So the next thing I want to look at is the period. Now there's sometimes when you're looking at the graph, it's easier to think about the period in this way. Whatever your B value is, and so if I'm looking at my first choice here, it's 2. If my B is 2, that means that I get 2 full cycles of the graph in the normal period. That means that between 0 and 2 pi, I should see 2 full cycles of the graph. And so if we look just from here to here, there we go. Hopefully you can see that we do have 2 cycles of sine between those lines. Between 0 and 2 pi, there's 2 cycles of sine. And so that means that my B is going to be 2. So I can eliminate G and H, which both have a B of 3. And so now I'm down to sine or cosine. And so we've got to figure out which one of these matches this graph. And the only thing that we have left is this horizontal shift, the plus pi over 2. So that indicates that we've got to shift to the left pi over 2. And I notice my squares are pi over 4, so I'm going to count to the left pi over 2, which would be right here. That's going to be negative pi over 2. And so then I go to the graph and see where we are. So that corresponds to that point right there. which is on the middle line. And so if I know if I'm on the middle line, that's got to be a sine graph. Sine is the one that starts on the middle. And it is starting on the middle and going down, and so that means that it is a negative sign, and so E would be our answer for number 10. All right, let's move to the next one. Now if you look at this one, notice that it's stretched out a lot. The graph that we just completed was kind of squished together horizontally, and this one is stretched out. And what that means is that my B is going to be a fraction. A fraction B stretches out the graph. And so just based on looking at the graph and noticing that, I know that I'm choosing from this list of equations because these are the ones that have fraction B's. It's not going to be any of these over here. So again, I'm going to mark the middle line just because I think that helps orient the graph. I have an amplitude of 2, but looks like all of my equations have amplitudes of 2, so that doesn't help. I really do need to figure out what the period is here. Now this one, looks like we can't even see a full cycle here. So if I mark, here's a minimum point and here's a maximum point. So I'm going to count how many squares go between those 2 points, if we can see them well enough on this copy. It looks like we've got 1, 2, 3, 4, 5, 6, 7. It looks like it's 8 squares. So what can I write? I'll write over here to the side. So that's 8 squares, and each square is pi over 4. And so that equals 2 pi. But remember, that what we just looked at is just from a minimum to a maximum. That's just half of the period. And so I've got to multiply this times 2. And my period, here we're figuring out period, my period is equal to 4 pi. If I know the period, then I can find B. B is going to be equal to 2 pi divided by the period. 2 pi divided by 4 pi. Pi's cancel, and that reduces to 1/2. So that means that I've eliminated A and B. I've got a B value here of 1/2. So I know I'm choosing between C and D. Now I'm down to the horizontal shift. Minus pi over 2 for both of them. So that means right pi over 2. So I'm going to go back up to my graph. I'm going to start at the origin, and I'm going to go right pi over 2, which is right here. And I'm going to go to the graph. And at pi over 2 on the graph, it looks like I'm at the maximum point of the graph. And that means that this is going to match cosine. Cosine is the one that begins at the maximum. And so that means we're choosing answer D. All right, let's go to number 12. Now on this one, if we compare this graph to the graph we just did in number 11, it is stretched out, but it's not quite as stretched out as the graph in number 11. And remember, in 11, that graph had a B of 1/2. This one is just squished in a little bit, and so the B is going to be 3/4. We can still exclude E, F, G, and H because this graph is still stretched out from the normal graph, and so we know that the B is some kind of fraction that's less than 1. That's what stretches it out. So I'm just choosing between A and B here. I'm going to, again, mark the middle line because I always like to have the middle line. And now I'm going to look at the horizontal shift. And this time they're different. So let's start with A. The first one is minus pi over 2. That means right pi over 2. So I'm going to go right pi over 2, which would put me right here. That's pi over 2. And if I go to the graph, mark that point right there, that point is on the middle line. And so I know this should be sine because sine is the one that starts on the middle. And it goes up, and so this should be a positive sign. And if I go back and look at answer A, it is sine and positive, and so that's the correct choice. Number 12 is A. All right, final graph. number 13. Now this graph has obviously been squished together, which means my b should be greater than 1. So I know it's not A, B, C, or D. We're going to be choosing from this list. And if you compare 13 to number 10, you can tell that it's a little more squished together, which could indicate that our b is going to be the bigger number. It's going to be 3. Another way, whoops, sorry about that. Another way to tell is to look between 0 and 2 pi. So if I mark this off right here and just count how many cycles of the graph do we have. And hopefully if you look at that there, I mean, they're not exact cycles because we're kind of starting in the middle of the cycle, but notice it's ending in the same place. And there are 3 cycles occurring between 0 and 2 pi. And so that means that my b value should be 3. All right, so I'm going to, let's mark off the middle line here at -1. Sorry, that's my dog walking by. Say good morning to Barkley. There's my middle line. And if I'm choosing between G and H, they have the same amplitude, same vertical shift, same B value. I'm looking at these horizontal shifts. It's plus pi over 4. And that means left pi over 4. So I'm going to go back up to my graph, and I'm going to start here at 0 and go to the left pi over 4, which is going to be right here, minus pi over 4. And, whoops, let me write that somewhere else. Wrote that right on top of the graph, negative pi over 4. So I'm going to go to the graph. Looks like that corresponds to this point right up here, which is at the top of, it's at a maximum point. And so that means that we're starting a cosine graph at left pi over 4. And so if I go back to my choices, cosine is choice H. All right, last 2 questions. We're going to write an equation for these graphs, a sine equation and a cosine equation. So the first thing that we need to do is try to, if we're going to do, let's do a sine equation first. So I need to sketch a window pane that frames in 1 cycle of sine. Now I know that sine starts in the middle and it goes up. And so let's identify our midline first of all. Looks like my midline is right here. And so I'm looking for a place where the graph is hitting the midline and going up. So I could choose this point right here. And I'm going to let that be the CD point for my window pane. So I'm going to sketch in down to the minimum. Here's the maximum. And then it looks like my cycle is completed right here. Okay, well, my pen stopped working there for a second. There we go. And here's the middle of my window pane. All right, so let's look at the window pane here and see if we can identify all of our transformations. First of all, this is the point CD. It has the coordinates. Looks like we've just gone right pi over 4, and we've gone up 1, 2 units. That's the coordinates of that point, so that gives me my C and my D. The amplitude, remember, is this distance here from the middle to the top or from the middle to the bottom. And so if I count 1, 2, 3, 4, it looks like my amplitude is equal to 4. And same if I counted down, 1, 2, 3, 4. So amplitude is 4. Last thing we need to figure out is the period. Now the period is how wide the window pane is. And here my window pane is 1, 2, 3, 4 squares wide. And then if I look at my units, each square is pi over 4. So I have 4 pi over 4s. And that, my 4's cancel out and I'm left with pi. And that equals the period. Now remember, that's not my B. I still have to calculate B. B is going to be equal to 2 pi divided by the period, 2 pi divided by pi, which is 2. So now we're ready to write our equations. Y equals, and what am I doing? I'm doing a sine equation, right? So my amplitude is 4, sine, b is 2, x, and we went to the right, pi over 4, so it's minus pi over 4 plus 2. All right, and then I also need to write a cosine equation. Now, when I write a cosine equation, the a, the b, and the d, they're all going to be the same. Y equals 4 cosine 2x, and then plus 2. The only thing that's going to change here is the c value. And I'm going to go back over to my graph, and so now what I'm looking for is an x-coordinate of a maximum point. Right here, cosine is at a maximum. And so if I go, oh, that's not the x-axis. Let's go down to the x-axis, and we're going to figure out what that is. It looks like it's 2 squares over, and so that would be pi over 2. And so that means to start a cycle of cosine, I've moved right, pi over 2. And so that's my 2 equations. Let's do one more. This time I think I'm going to start with cosine. So to frame in a cycle of cosine, we want to find 2 maximum points and draw the frame in between those 2 points. So here we go. There's cosine, middle line, and here's the other middle. All right, so I need to find the coordinates of this point, and so I'm going to count the squares. 1, 2, 3, 4, 5, 6, 7, 8. So it takes me 8 squares to get over there. And then I notice that each square, my units here, are pi over 3. So 8 pi over 3. That's going to be my c value. And it's negative because we went to the left. Well, the c value is negative. When we put it in our equation, of course, we're going to put plus because we've moved to the left. And then my d coordinate is negative 1, 2, 3, 4. D is negative 4. So those are my coordinates here. Negative 8 pi over 3, negative 4. All right, next let's figure out the amplitude. Remember, amplitude is the distance from the middle to the top, and in this case, amplitude is equal to 2. So my A is 2. Last thing that we need to figure out is the period. Period is going to be how wide our box is. So I'm going to count those squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, so for period, it looks like I have 12 squares, and each square is pi over 3. And so that simplifies to 4 pi. Now remember, that's still not my b. B is going to be equal to 2 pi divided by the period, 2 pi divided by 4 pi, and that reduces to 1/2. So now I've got all of my transformations. I'm ready to write the equations. Y is equal to 2 cosine 1/2 x. And remember, for mine, I went left 8 pi over 3, so I'm going to put plus 8 pi over 3, and d was minus 4. Now when I write my sine equation, a, b, and d are all going to be the same. 2 sine 1/2 x, and then minus 4 here at the end. I just need to find a new c value. Sine starts in the middle, and it goes up. And so I'm going to choose this point right here where the graph is crossing my middle line, and it's going up. And that looks like it corresponds to pi over 3. And that's right pi over 3 minus pi over 3. And that concludes our test review video. See you guys on Monday.